So before I start the demo, I will take it that none of you have heard about MindsDB before, so I will explain a little bit what we're trying to do and where we are in the journey. At the end, building a company is, you have an idea of what you want to accomplish, and you take steps to get there. So by no means think that MindsDB is a finished project. It's an ongoing project. It's an open source project that started with the idea that AI can make every organization smarter. And we felt that, at least for our taste, it was going to be cool to make that vision possible, but making it very simple for a lot of developers. And we felt that a good way to start was building infrastructure. And that's what the open source project does. It's a middleware or a platform that allows people to connect data with AI and ML capabilities. I'll describe it a little bit more into so many of you are engineers. How many of you use SQL databases or relational databases? Yeah. Anyone that has done some code has played around with one. And at the end is we build applications on stacks. And for us, it felt that machine learning and AI could fit in the data layer. And there were abstractions that could make it very easy for simple workloads. And at the end, MindsDB is meant to make it easier. I mean, you can do a lot of these things outside of MindsDB, but MindsDB wants to simplify the workflow of connecting data to machine learning and AI models. So fine-tuning or training from data that exists in your database, or using data that is in your database, passing it into a model, and then putting it back into the database. So I'm going to walk you through a simple demo that does the latter, especially because we're in this part of the journey of MindsDB became a good open source project, but now we want to build a cloud version of MindsDB, and we're releasing smaller features one at a time. So this is the one that we're starting with. I encourage all of you to go and visit the GitHub repository, and we have more than 700 contributors. And if you like coding and contributing, there's a lot to do as well. But let's go for the demo. There's a lot of data that people have been having on databases for a long time that is just plain text. And until LLMs that were reasonably good, a lot of the problems of extracting data from these text fields were dealt with traditional ML. Say, for instance, if you want to extract labels from documents, you will use classifiers or you will use other label extraction techniques. And these things worked, but LLMs can do a better job. The problem that we had with LLMs is that they got pretty expensive. In a traditional database, you may have not just one document, but you may have thousands of documents, millions of documents. And at a few dollars of inference per document, you will end up going bankrupt if you wanted to do this in a row-by-row basis. So that has changed a lot, and a lot of the open source LLMs got pretty good. And inference cost, it's a competition to the bottom. So now we get more than 1 million tokens for 1 cent or things like that. So these things now are viable, and a lot of the problems that people used to solve traditionally with traditional ML models can now be solved with LLMs at scale. And for example, you may have documents such as, and this example may be boring, but it was one that we could put up in 10 minutes before this, but imagine that you have a whole bunch of documents such as insurance policies, and these things contain a lot of text. You may want to extract questions from this particular document, such as what is the name of the person in this policy, how many people are covered by this insurance policy, what is the address, when does it start, when did it end, and these are questions that the person that has this problem can ask in natural language. If you wanted to go in the traditional way, you will have to train a model to get these labels out. With an LLM, you can ask a question. Now, with the newer LLMs, you can actually send all the questions at once, so you don't have to run through the same document multiple times, because it gets pretty expensive, especially if it's not just one document, but many documents. So the experiment that we wanted to do is, okay, how good are these LLMs at doing this? If I take Llama 2, and I send, 10 questions from one single document, will it do it? We have this company that works in our office. They do this for legal documents of all kinds. And their prototype was actually really nice because it does what it's supposed to be doing. It helps lawyers get data from documents that get uploaded, but it gets pretty expensive. Now, with our technology, this thing gets pretty simple because you can just pass a document, all the questions, and then in one pass you extract this data. It will all fit in a second. The second demo that I have for you guys is of the same family, but now it's kind of leveraging on the power of LLMs to understand actual documents and understanding, the content of them. So you, for instance, in this case, you may want to know if multiple documents are talking about the same person. Say, for instance, if they ask you to upload a policy, an NDA, and bank statements, you may want to trick the system, you may want to upload things that may be similar to you. A traditional approach to machine learning will make this problem really difficult because you will have to create a lot of label data to are these two documents the same or not. With LLMs, again, the power is you can say, well, read this document, read this other document, and see if these two are the same. And again, in a real-world scenario, you will have not just one document, but again, millions of documents that you want to compare. So that's kind of like the type of problems that MindsDB wants to solve. Anyway, I'm gonna wait. So MindsDB has a few abstractions, but the first abstraction that we bring to the table is being able to treat machine learning models as tables, so that you can query a model like if it was a table, but you can also join models with data. And then you can have constructs on top of that, such as you can create views that join models with other data and then that model with another model, so you can create pipelines of that sort. And what I'm gonna show you is the first example. Like I'm gonna connect a database. In this case, it's a Postgres database. I had already connected to it, but we have a table that has customer and policy. And these policies, are hefty in text. What I want to do is I want to create a model. In this case, I'm going to use Llama, and I'm going to tell it, hey, why don't you extract a JSON document with this information, like the ID, the full name, the last name, the type of coverage, when this document started as an effective date, and when does it end, the employer of this person, and the type of insurance, et cetera, et cetera. Yeah? And you can keep asking questions. And the idea is that this all run in one single pass to the LLM. And of course, there are many LLMs. In this case, I already know that this one does a good job. All the other ones, like the smaller you get, they can only answer a few questions, and then after that, they just start kind of like hallucinating. But you can create a model like this, and what you end up doing is I want to select from the policy, and I want to join each of the rows that I have with that model, and I want you to give me the output of that JSON. So that's what I want to do here. And it's actually pretty fast because, again, this is still a relatively small model compared to like GPT-4, et cetera, but it does the job. It actually extracts the data that you want it to extract. And again, the purpose of MindsDB is to do things that are data related, that involve data that you have in your database, and to do it in a way that is very natural to a developer. So here we're extracting these documents, or this information from the documents. Just to read it better, I'm gonna tell it to expand that JSON a little bit. And anyway, if you were to look at the policy table, it's a whole bunch of documents. Here now you're getting actual data that you can use for down the stream tasks or your application, et cetera. For the second document, it wasn't able to extract information. That's because that document is a little bit messed up. But for most of the documents, it does a good job. Anyway, then you can automate pipelines such as you want to create a job that every second looks into the database for new documents, and if there are new documents in the database, then join that with the model and insert that back into a table. This is a job that we're running already, and if we look at that, Postgres. And that table. then we can see that these things are being kind of updated on real time. Anyway, that's first example. The second example is I may have two documents, and I want to compare these two documents are the same. And again, I don't want to do this just with two individual documents. I want to do this with thousands of documents or hundreds of documents, etc. So I created a simple view that joins these two tables. The way that these two tables look like is something like this. So you have the policy, and then on the other side, you have the bank statement. If you can see here, it's very obvious that these two are not the same people. One is Dorothy Claus, and then the other one is something else. And again, we have this for a whole bunch of documents. What we're going to do is we're going to tell it, okay, create a model. In this case, use Mistral. And given the policy, again, you tell it what column you want to read from. And given the other document, which is a statement, try to tell me a degree of probability that these two things are the same or not. And once you create the model, you join that model with the table that we had. That's what we're going to do here. And it actually does what you tell it to do. So as you saw in the first example, they were not, and it is pretty good. It understands, well, the likelihood of these two people are not being the same is very low. It actually gives you an explanation that makes sense. And it does the same thing for all the documents that you have. Anyway, the idea here is to make it very simple for people to do this type of tasks that sometimes are a pain in the ass to do if you're going to have to get out of the database to perform. And then with MindsDB, we just make these things rather trivial. That's the first demo.